last Tuesday's lecture. Okay, now we're going to talk about a totally different topic we have to cover. We're going to cover files, plotting. Then you're going to end up with machine learning libraries. The first one is files. I have some files created. I'm going to also put the files for you. But what's important is how to, is the pattern. It is, if you have a file and you want to access, here's what you have to do. There's a command file open. You need to open a file. Then you have to know the path. So the path for my file is under C:users acme desktop demo file. Okay, that's the file name that I have. Then I say print f.readline. So what's going to happen here? Let me just show you the file first, so you can see what I have in my file, and you're going to see what's going to print. So the my file, it has just few lines, just for demo. Do you see my file?
You mean the one you put
Yes.
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 So this is just a small file, but the concept is just, it doesn't matter how big the file is, because you're going to see I'm going to use a large file and you're going to see. But the concept is I have a small file here I created. I call it demo file as a TXT file, and that's it. That's all I did. Okay. It has 1, 2, 3, 4 lines. Okay. The first one you say hello, welcome to demo file, and this is file for testing purpose, and so on. Okay, you got it. And this file is on my desktop. So the location for this file is this right here. This is my location. Okay, so this is my location. If I write this one here, what's going to happen? You notice it's going to print only the first what? The first line of the file. Because I did not print everything. I just say, okay, I just want to print the first line. So read line means what? It's like I'm saying, go to the file and read only the first line from the file. Now, what if I want to read the whole thing? I want to read all the content of my entire file. Now, first of all, is this clear to everyone? Because these are new topics for you. Is this clear? And of course, I'm going to upload all this for you guys again.
Yes.
Okay. Now, if I want to read all of them, yes, go ahead. Does anyone have a question? Okay. But if I want to read everything, what I'm going to do, I'm going to use a loop. And within this loop, what I'm going to do, I'm going to say for X in file, print X. It's like I'm saying, I want to go ahead and print what? And print the entire file that I have, and by go to the entire file and print all the content. So if I run this one here, you see it print all 4 what? All 4 lines for me, because the file has only what? It has only 4 lines for me. And remember one thing very important, whenever I'm using files, you have to start by opening the file first. If you don't open the file, nothing is going to happen. And once you open the file, after you finish with it, you have to what? You have to close it. That's very important. Now, even though if you have a file, you know the file can be in, you can write to the file. So what you can do, you can write to the file. So here's what happened here. If, for example, I go to my file here, but instead of using R, remember R is for what? For read. I'm going to use something now. I'm going to use A for append. So what does mean append here? It's like I'm saying, I want to open my file, which is demo file, and I want to add a new line to it. So that's why I say F write instead of F read line. I said write. It means I'm going to open the file first, then I'm going to add this one here. It say the file now has more content. So I'm going to add the new line. And remember, the line is going to add all the way at the bottom. Then I'm going to close the file after I read it. Then I'm going to open it one more time here. Then I'm going to read the file, the content of the file, and you are going to see it's not going to be only 4 lines. It's going to be, it should be 5. So if I run this one here, you notice here, say what? Here is my 1, 2, 3, and 4, and here is the 5th one here. Say now the file has what? Has more content. So it added what? It added more line to the file. This is basically how we can add to the file. You can read the file and you can add anything to the file if you want. Okay, guys, this is when you use the append, because this is very important when you use append and when you use write. So append means what? You're adding to the existing file. Please pay attention. When I'm going to show something different now. The append means what? You're adding to what? To an existing file. Look what happened. What happened if I use, instead of using the A for append, I'm going to use the W. So what the W mean? It means what? I want to write. What the W means? It means I want to write. But in this case, when you use the W, it's like you're saying, open the file and override everything that you have in that file. Means open the file and what? And override everything. So what I'm going to do, I'm going to say, I'm going to write, put W for write. I'm going to say, whoops, I have deleted the content of my file. Then look what's going to happen. When I open it again and try to print, I'm going to see whether it's going to print my files, my 4 lines here, or something different. So if I run this code here, look what happened. It said, whoops, oh, I have deleted what? The content of my file. Now my file does not have the 4 lines anymore. They're gone. My 4 lines that I have, they are what? They are all gone. And let me show it to you in the real file, file. If I go to my file here, okay? If I go to my demo file, you guys see my demo file?
Yes.
Okay. If I open the file, look what happened. Oh, it's not saved. There we go. It's called, there's my file. Because I have changed the name to it. I have changed its name. If I open the demo file, no, this is Bowie inputs. I know I have deleted it. I'm just trying to open the file to show you it does not have the content that was there. The content that was there is gone. I'm just trying my file. Just give me a second. I'm just gonna find my file. And open it for you so you can see it. And what you are going to see, anytime if you put write, what's going to happen is going to override the old ones. These are the old ones. And here is the new one. Here is my new one. Here you go. Look at the new one. Now it say what? Whoops, I have deleted what? The content of my file. Why? Because what I did when you put the W, what the W means, it means you want to override the existing file. Override means what? You want to override the existing file. You don't want to append. So that's very important to understand, because there is a difference between append and write. Append means you want to add to whatever you have. So append is not going to delete anything. All the append does is add more to what? To what you already have. But when you try to write to the existing file, what's going to happen? It's gonna what? Is going to delete everything. Okay, it will take to go to the file and it's gonna delete what you have in the file. Okay, now let's assume we are done with the file and you want to delete the entire file. Let's assume we are done with the file and you want to what? You want to delete it. So if you want to delete a file, look what happened. There is a command that will allow you to delete the file after you are done with it. Let's assume you have a file that is very large file occupying a lot of space. There is a command that will do it. You're going to import the operating system. There's a command. And all you have to do, you're going to say OS that pad that exists. It's like you're saying, if this file exists, what do you want to do to it? You want to remove it. If this file exists, you want to remove it. If it does not exist, it will say the file does not exist. Okay? And when you run this one here, look what's going to happen. If I run this code, it went through the file and it find the file and delete it. But when I try to open it, say what? No such file. Because what happened? Because what happened here? It deleted the file. The file is gone. And when you try to open it, say the file does not exist anymore. Okay. So if, for example, you are using a lot of space using a file, and you want to free some space, yes, you can do it. But you have to pay attention. If, for example, you want to, you still want to use that file somehow later on, make sure to have some kind of a backup, because if you don't use any backup, the file is gone. If you don't use any backup, your file is gone. So this is very important. Now, this, if I'm talking about a small file, what if I have a large file? And I'm going to show you an example. What if I have a large file? So I can also what? Open a large file. And the file I have right here, and also I'm going to send you this data. I have cars, which is basically a CSV file, which is an Excel CSV file that contain a lot of data. So to open this file here, I'm going to use a data set. So we say what? I'm going to use in pandas.pd now. Pandas is one of the libraries I'm going to discuss with you later on as well. Okay. Okay. So when I go to pandas, I'm going to say, okay, I just want to read the file that we have that I have in this what? In this Excel file, which is under what? Is saved under CSV file. So if I run this one here, this file here that I'm going to add to you guys, it has a lot of, it has what? It's busy right here, because the content of this data set is big. So it has a lot. So as you can see right here, so we have a lot of data right here. It contains 407 rows and 9 columns. So it contains car, miles per gallon, cylinders, displacement, horsepower, the weight, acceleration, model, and origin. So this is a big file. And you see, when you see these dots here, it's not displaying everything. It means that you have more. That's what that's mean here. And these are some of the things that if you go to talking about data sets and data analysis, you're gonna analyze data that is even bigger than this. Okay, guys. This is basically how we open a file and how to access a file. Does anyone has any question about opening and accessing a file?
Yeah, I do have a question. When the other time that you said append, I understand that W after the word is right. So if we are to add something to the file, we are appending, right?
If you want to add, yes, you're appending.
So how does that code looks like?
No, if you're append, that's what happened when I did the A. You notice it added another line to the file. Do you see that?
So you just put A where you wrote the W, right?
Exactly, because what the W mean, it means you want to override the existing file content. If you put W, it's not going to add to the existing content. What the W will do in this case, it will go to the file and it's like it's going to do two things. It's going to erase the existing file and put a new one.
Okay, so the F, the open F and X, what does that? Can you go back to that file?
Which one are you talking about? You mean the first one? The append? Okay, let's see. Let me go to the file.
It could be either of the two, either append or W, where you put the W.
Yeah. I just got it. You're talking about this one. Yes. What's your question? Yes.
So the ones that say for X in F, print X.
Yes.
What does that mean?
What that's mean here? It means I want just to go to the file. Remember the file, because I opened the file here, right?
Yes.
Then I put W. It means I override the existing file. Whatever it was in the existing file, it has been replaced by this statement right here.
Correct.
Okay. Then I close the file. Now I say I want to see what happened to my old file. Then what I did, I just open it again. I put F equals open, but this time I want to open it not to write, but I want to open it to read. That's why I have R here.
Okay, open to read. Okay.
It's open to read this time. Then what I want to read everything in the file from the beginning to the end. So if you want to read everything in the file, you have to use a loop. So what the loop said, for X in F, it's like I'm saying for every element in the file, print it. That's what that means. Take elements one at a time, put in X and print X. So this loop is going to keep reading file, the element in the file, one after the other until it finish everything. Then it will close the file.
Okay, yeah.
Does it make sense? That's why I have the loop here. It will go one element at a time, and it will read every element in the file. That's why you have R. That's why I have to pay attention here. W and R and A. These are very important. The A is to append. It means you're going to add to the existing content of the file. The W is to override. If you have a file that has some content, if you use W, remember, it will override the existing one. And this is very important to remember, because if you override, your old file is gone. That's why you have to be very careful. And if you put R, it means you just want to read whatever you have in the file. It does not modify, it's just going to read. Does that make sense to you guys?
Yes.
Any questions? Any other questions? Any other questions?
Yeah, Doctor, can somebody replace the for loop, the variable s with another variable?
You can do whatever you want. It's just a variable.
Any variable, all right.
It's just a variable. You can call it whatever you want. Remember, the variables you are in control. It's not a keyword or anything. It's just a variable. Okay. Any other questions? Any other questions? All right. Now the next topic is plotting. And you are going to see if you are going into data analysis and stuff when you open a file, so you can get the file, you can get the numbers, you can put the files elements into a list, and you can plot the result. So here's an example of plotting. So when you plot, there are many things we can do. The first thing is what? If you want to plot, you have to import a library. The library we're going to talk about is called what? Matplot library. So the command for this one, you're going to put import matplot library dot pyplot, which is Python plot, as PLT. PLT is short for plot. So instead of keep using the whole thing here, I'm just going to use the short PLT. That's why I have as PLT. Does it make sense? All right, let's assume I have the following data. I have data called, I have 2, 2, 2, 4, 4, 6, 8, and 10. Then what I'm trying to do here, I'm just trying to plot what? A histogram. So to plot the histogram, you just put the PLT, which is this short here. This is short notation for the whole thing here. That hist, H-I-S-T, that's a keyword. Okay, and what I'm trying, it's like I'm saying, I am going to plot a histogram based on the following data. Based on what? Data, which is basically 2, 2, 2, 4, 4, 6, 8, and 10. And what I'm trying to add, instead of just plotting just like this, I want to add more things. I want to add an x-axis, a y-axis, and a title. So in the x-axis, I'm going to have the word value. In the y-axis, it's going to say frequency, and the title say histogram. Then after I do all this, then I'm going to say, okay, show the plot. If you don't put PLT the show, it's not going to show anything. Okay, now it's ready. So if I write this one here, you're going to see it plots basically what? My histogram right here. You see it? So like I said here, the value, the x-axis say value right here. In the y-axis say frequency. And the title say histogram right here. And these are my values. Any question about this so far? Any questions? Okay. Let me give you more stuff about plotting. The Python, it can plot so many different type of figures. Okay. You can plot different type of figures. You can have a histogram, can have bar chart, you can have flow chart. What do you call a pie? Can have so many things. Here's another example of plotting here. I'm going to use all in the same place, but when I send you the lecture, it has everything in separate. Okay. This other example that I'm going to show you right now, and let's put it right here. You can replace this. Now I have different type of data this time. I have X values, which is A, B, C, D, and E. And I have Y values, which is 2, 4, 6, 8, and 10. But what I'm trying to create this time, I'm going to try to create a bar chart. I'm going to try to create a bar chart. And in this bar chart, I have some layout. So I'm going to show the X value, which is X, and in the Y values, which is Y. So X, we're going to see A, B, and C. That's what you're going to see in the X axis. Then in the Y axis, you're going to see basically the numbers from 0 to 10. Then and what's going to happen is going to just print the layout. The title is going to say bar chart, just like this. And in the X axis is just going to say X axis, and in the Y axis is going to say Y axis. But you can change this to whatever you want. So if I run this one here, now I have a different type of chart, as you can see right here. So here's my X axis, here's my Y axis, and here's my title. Okay, and like I said, this you can do so many things. These are small, but this chart, it can be plotted when I'm talking about even large data, very large data. Here's another example, but this example I'm going to show you now, it's an example of line chart. To show a different type of chart that you can create when I'm talking about. So this one here, what's going to do is going to create a line chart based on the following data here. I have my X axis, 1, 2, 3, 4, and 5. Y axis, 2, 4, 6, 8, and 10. Then what I'm trying to do here, I'm trying to plot a line chart. That's why I have the X and Y. And you have X axis, Y axis, a line plot. These are my X and Y labels and the title. So if I want to show the figure, you're going to see what? A line chart right here. And that's what I have right here, line plot. Okay. I'm going to show you two more charts. Then you're going to move on from there. Another type of chart that you can have. Okay. I'm going to use a scatter plot. And at the same time, I am starting to discuss some libraries, by the way, here. This library that we are using here is called my plot library. It's one of the libraries that is very famous library in Python that will help you basically plot different type of graphs, as you can see right now. This is one of the famous libraries to help you plot anything you want as far as graphs is concerned. The next one here is called, the next library is called what? Seaborn library also. So what this one is going to do is going to plot what? A scatter plot. A scatter plot. So it's going to form like a form of what? Of dots to show you the distribution of data. So here we don't have a big data, but of course, when you're talking about big data, you're going to see the distribution that is a little bit different. So this is the data is what is scattered here. So this is how you're going to see the scatter plot. And I have another example that I'm going to show you later on even with colors, and you're going to see how this stuff is going to look like. And let's add one more, which is basically the pie, before I go to other colorful plots. The next one I'm going to show you is a pie.
Professor, hello?
Yes.
I didn't get the difference between matplotlib and seaborn.
It's just this one here if you want to have scatter.
So seaborn is only for scatter?
Scatters, yes. And I'm going to talk about libraries in a few minutes, and I'm going to show you how seaborn works as well.
Okay.
Okay. So if you look at this one here, is another example, but this one is using what? A matplot library and also NumPy. So what this is going to do here, because I want to create basically a 2D pie. So you're going to see a 2-dimensional pie, but this pie is going to have a shadow. What it's going to look, it's going to show it like it looks like a 2D. See this one here? It has like a shadow right here. So this is another type of plot that you can do. So all this, what I'm trying to show you right here, all these different figures or different graphs that you see here, you can apply, you can use, you can apply when you have data. And data, when you talk about data analysis, of course, we're talking about large amount of data. Large amount of data. With large amount of data, you're going to see the figures are a little bit different. With a large amount of data, we have a different type of graphs. That's what I'm going to show you when I'm going to be talking now about libraries. And I'm going to show you one example about some data sets. And you're going to see the difference when it comes to plotting. Any question about this? But I think it's straightforward. Just need to know your data and start basically what? And start plotting.
Yes, the explode matrix. I see something is in the first
Which one?
first position, 0.2. Is that the magnifying or the?
Yeah, this is for this one here. For this apple right here. This is just the shadow. How big is the shadow is?
Oh,
Yeah, that's exactly what it said. If you for example put 4, you get look at the shadow is going to be different now. See the shadow is good difference. It's gonna give you the it will explode because
all right.
exploding the pie and adding what? And adding a shadow to it.
All right.
You see it? And if we put +1, it's gonna be a little bit closer. So just exploding the pie and adding the shadow.
All right.
Okay.
All right.
Okay. Any questions? Any questions? Okay. Now we're going to be talking about the last topic here, machine learning. We're going to talk about machine learning. So what is machine learning, or what is library basically? We're going to talk about the libraries in what? In machine learning. So Python basically, it contains, I don't know, it contains a lot of libraries. Some they say it contains thousands and thousands of libraries. That's a lot. There are so many libraries that Python contains. Okay, we're going to just try to use only a few of them. Very, very few, like a handful of these libraries, because there are so many libraries that requires maybe a lot of time to study all of them. Okay, and we might not even study all of them, but we're going to try to do just a few today and see how this stuff works. Now, let's start with some of the command that maybe if you are in this field, it's going to help you a lot. The first library I'm going to talk about is called NumPy. Okay, so let me put some examples for you here. Then you're going to run each one separate. So NumPy basically is what? Is a popular Python library like for multi-dimensional array and matrix. Okay, when you use NumPy, we use for what? For this reason. We use if I want to what? To use multi-dimensional array, and also we talk about matrix processing, because basically what, like I said here, it can be used to perform a great variety of what? Of mathematical operations. So let's see some of the examples here, how this stuff works. Now, if you look at this one here, let's first of all, I'm going to use NumPy. If you want to use any library, but first of all, you have to import it. You cannot just go ahead and start using the library without importing it. It's like you're asking for permission for the interpreter or the compiler to allow you to use the library. If you don't import it, it's not going to work. So the keyword to import is import. You put import followed by the name of the library. In my case here, it's called NumPy as NP, because again, we use NumPy short as NP. Now let's create a 1D array. We're going to create what? One-dimension array. So to create a one-dimension array, we use the built-in command array. So that's a built-in command by the way. So you put a equals np.array. So what's going to happen? Now we're creating a one-dimension array that contains the following elements: 1, 2, 3, 4, and 5. Okay. So what happened with NumPy? It helped me what? Just create the array, because like as I told you, so the NumPy, it works a lot with what? With arrays. So this is how we create a one-dimensional array. Just put np.array and it will basically create a one-dimensional array for me. So this array, it contains the value 1, 2, 3, 4, and 5. That's all there is. So if I print A, it's going to print an array that contains all the elements from 1 to 5 of array of one dimension. If I want to create an array of dimension 2, NumPy will help me also do that. So the same thing. You just put np.array and it will help me create, because like I said, the library here, it uses multi-dimensional array and matrices to what? To perform a lot of mathematical operations. So to create two dimension is the same way. Just put np.array and put the array between two brackets this time. So the first set of brackets, the second set of bracket, then you put an external bracket to show the compiler that I'm talking about a two-dimensional array. Then if I print this one, and you're going to see when I run this one here, it's going to print basically what? An array for me. Now, the next example that I showed, what if I want to create an array of zeros? I want to create basically what? An array of zeros. So if I want to create an array of zeros, all you have to do is just put np.zeros. This is a command, by the way, and you put 3 by 3. So what that's been here, you are creating basically what? A 3 by 3 array, and all these elements contain zeros. So in every position in the array, it contains what? The value 0. So this is how we do it. That's basically a command. And if you want to use, if you're going to create an array that create a random values, you're going to use basically what? The random operator as well. You're going to put np.random.rand, and you put comma 3. What's going to happen is going to create an array with random values. Okay. And if you want to add 2 arrays together, here's what you have to do. You're going to create 2 arrays. The first array is it's a F. The second array is G. And to add 2 arrays, just put H plus G, and you put in another array. And when you print H, it's going to print the sum of what? Of these 2 arrays. And if you want to multiply the same way, you're going to take F times G, and you're going to multiply 2 arrays. If I run this one, let's check the output, and let's go over this output for it. Now, here is the example. So the first array dimension 1, that's what you see right here. That's exactly what we have here. So with the help of the library NumPy, we were able to create basically what? An array of dimension 1. That's what happened right here. Now, the same thing with NP again, we create what? An array dimension 2. That's what you have right here. And the third command that we say is zeros. So basically I have what? I just put 3, 3. So this function, this function is the built-in function. What it's going to do is going to create a 2-dimensional array, a 3 by 3, but all the values are what? Are zeros, are set to what? Are set to zeros. Okay. And the next one, as you can see right here, it put what? An array of 1s, and that's exactly what I have. So these are zeros. This is an array of 1s, but this is the 2 by 2. But remember, all these are built-in functions. The 1s and 0s, they are all built-in functions. And the next one, we have just an array in random, and in random it takes any values. That's what happened here, because we did not have a set of set values. And the sum, as you can see here, it will add the sum. So 1 plus 4 is what? Is 5. 2 plus 5 is 7. And 3 plus 9 is 3 plus 6 is 9. So this basically the sum of 2 arrays, and that's what you see right here. And the multiplication is the same again. With the multiplication, we take 1 times 4 is 4, 2 times 5 is 10, and 3 times 6 is 18. And that's what you see right here. This is the first library, NumPy, and that's what it does when it talks about what has to do with what if you have anything that has to do with matrices and or multi-dimension arrays or 1-dimension array, you use basically what? The library NumPy. Any question about this one here? Here's an example, for example, that you can also use with NumPy. Let us show, for example, you want to perform some kind of calculations. NumPy can calculate this. Let's just put, I'm going to put it here on the top.
Yeah, Professor, one quick question.
Yes, go ahead.
All right, how does the array, how does it arrange? Does it read row, column, or column row?
What do you mean when you are reading the?
That is like the first element.
Yeah, it goes row first
in a 2-dimensional array.
No, 2-dimensional array. It goes row, column. It goes row, column, 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 column until it's finished. Then if it's 2-dimensional array, it will start with row, then it go column, 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 column.
All right, I got it.
That goes to the next row, then start again from scratch, column, 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 and keep going that way. Make sense?
Yeah, thank you.
Okay. And this one here, if for example you want to calculate, let's assume you have an array 1, 2, 3, 4, 5, and you want to calculate basically perform what? You want to calculate the mean of what? Of this array right here. Okay. So what happened? You can use NumPy also will help you perform this mathematical operations. So basically you're gonna square this. So array time to power 2, and you're gonna take the mean of this. So if I run this one here, there you go. It's gonna give you the answer. Let's go up to see it. And the answer right here is 3.0. That's the mean of the array. And you know what the mean is, right? The mean is the median, correct?
Yes,
You guys
sir.
are math major, correct?
Yes.
Okay. The next one is pandas. Is another library I'm going to show you now. Before I go to pandas, there is another library. I'm going to show you right now. And what this library is going to use, basically, there are, it's going to load, I'm just going to use here. The next one is called Scikit, or it's called Scikit-learn. This one is very powerful when we talk about machine learning. There's another library here that talks about machine learning here. And it's built on NumPy and SciPy. It's built on both of them combined. And what it does here, it support the classic, basically, supervised and unsupervised learning of algorithms. So what happened here? So to show an example here, we're gonna, by the way, we're gonna import, we're gonna load the iris. The iris is what is a data set that belongs to the machine, that belongs to Python, and it's loaded automatically. Okay, you don't have to worry about this one, where to find it. Just put import and it will import for you. Okay, and what this example is going to do is going to calculate the accuracy. And by the way, this Scikit, it does many things when it comes to data set. But I think since we're in a very quick hurry, there are so many things we need to discuss before I can give you the detail. But all I'm going to tell you here, it talks about data set. It can give you predictions. It can give you statistical, like when you talk about probabilities. It gives you so many things that has with math, statistics and math probability and math predictions and so forth. Or it will predict some kind of data. If you have, for example, data that you need to analyze and you want to come up with some predictions and accuracy, you can use that.
It can also give heat maps.
Say again?
It can also give heat maps.
Yes, it can give you all of those. Yes. So if for this one here, just when you run this one here, it gives you basically just an accuracy of this data that you load basically from the compiler. If I run this one here, the accuracy, it will show you. Let's see what's the accuracy here. It's 0.9666667, which is almost 1, which is basically, it's very almost very accurate.
That's very high.
Very high, extremely high, extremely high. The next one is pandas. Okay, and I'm going to show you an example of this one here.
And
yeah, let's look at this panda here and show you how does it work. And I'm going to show you examples. And all these libraries are very powerful. And when you guys, if you're doing machine learning, this is going to help you a lot. And at the end, I'm gonna have a lot of resources that you can go back to, and you're gonna review all this stuff as well. So Panda is another Python library that is built on top of NumPy. And it is basically, like I said, responsible for preparing high-level data sets for machine learning and training. So let's assume I have the following here. I have a dictionary here that I have names, age, gender, and salary. And what we're going to create here, we're creating basically a Panda data frame based on the data that I have right here. And we're going to print the following. We're going to print the first 5 rows of the data frame. That's what's going to happen. That's what I'm going to do. And we're going to calculate the mean salary. Then we're going to calculate also what, then we're going to print it. And you're going to, based on what? Based on gender. And all we care about, we're going to print what? The female data frame here. So what's going to happen here in this example, we're going to create dictionary. And what Panda is going to do, it will print the first 5 rows of the data frame using as the head. Then also it's going to calculate what the mean salary using the mean and print it. And also it will filter the data frame to show only the females using the Boolean indexing. So if I run this one here, here's what's going to happen. So as you can see here, it shows basically the name, the gender, the age, the gender, and the salary. And also it showed the main only for what? For the female. I see the gender right here. This is for the entire data. This we have the first 5. Then when it goes to the main, also for the female, it shows only the female. We have Sarah and Mary, the age 32 and 18, the gender female, and the salary is what? 70,000 and 30,000.
Professor,
Yes.
when you remove the function of print and you just write female underscore DF and then you run, I think it gives a better format than this.
You mean for the last print?
Yeah, you remove the print and the parentheses and just have the name of the data frame, female underscore DF. When you run, it gives a better format than what we have.
Yeah. So you can do it without the print. You can just do this.
Yeah, and when you run, the format is better.
Yeah, it's different.
Where is it? It has disappeared.
Yeah, that's correct. Because when you're talking about data sets, you don't really have to use the print command. Anytime you're using the data set, you don't need to put the print command. You just put the data name and it will print by itself. Because by default, when you put the data name, it's like you're saying to compiler, I want to print this one, and it will print for you. And that's true. Any other questions? Any other questions? Okay, another example. I'm gonna show you an example of Seaborn. I'm using the same place again, but remember, when you receive the lecture, everything is separate. Okay, I'm just putting everything in one place because of the space. So what this one is going to do now, in this example, we're going to load again the iris data set from the Seaborn built-in data set. And what you're going to do, and we're going to create a scatter plot. Going to create again what? A scatter plot. And this time what you are going to see is going to create the scatter plot, and also it will add color to differentiate between what? Between different species. So let me run this one here, and you're going to see how this is going to look. And you remember this, the example I showed you before, I said print scatters, but this one is much better. This one is what happened here. It shows different type of species. We have sepal width and sepal length, I believe. And here is the data set. And based on the color, you can see which species that we have right here. So we have Setosa, we have, these are some of the species that are coming from when you load this data set right here. Okay. And the data set is coming basically from Iris. So you don't have to create anything. You just go ahead and load it and it works for you. And another one that I'm going to talk about now is another example. Now what you see based on these examples, how powerful these libraries are and what you can do with data. You can basically analyze data in so many different forms. So you can analyze data on graphs. You can analyze data based on numbers. You can analyze data with so many things. And also adding colors is another example of data analysis. And if you look at the way this data is scattered right here, so we have principal component 1, we have principal component 2, and you notice also the scattered data based on colors as well. And all this is because of if you didn't have the libraries, you would not be able to use any of these right here. And like I said, the Python has thousands of libraries, and I just show you like 5 or so. And there is, I have also some useful resources that I'd like you to return to. One is called realpython.com, and we have realpython.com tutorials and machine learning. That's another one. You can also return to W3 Schools, and you can go to python.org and learn python.org. Those are some resources that you can return to, and it will give you a great deal of detail. Okay. Like I said, this requires a lot of time, of course, a lot of experience and a lot of hands-on practice. But this would give you, if you go through this one here, it will give you a lot of hands-on practice because it has exercise as well. You can practice, you can see the answers, and you can play with all this right here. Okay. And this takes care of these lectures, unless you have any questions.
So are you going to load this one too on the charts?
Say it again.
Are you going to load this file too on the charts?
Yeah. I'm gonna load this. And by the way, and I'm giving you something for practice. I have about, I think it's about, I create like seven exercise programming assignments that I would like you to do for you to practice. You're gonna basically practice everything we did today. Okay. So did you guys have a chance to load the one I put for you in the chat?
Yes.
Okay. So I'm gonna load the next one right now, and I'm gonna put in the chat.
Professor, are you going to give us the data set for cells data?
If I'm giving you what?
For the assignment number 4, that is cells data. You are going to give it to us?
Oh, the data set. Yes.
Okay.
I'm gonna give you data sets. Yes.
Okay, thank you.
Yeah, you're welcome. So that's it. And let me just load the next one here. Do you see it? And also, I'm going to load
Yes.
data for you. I'm going to load the cars for you, because you're going to need that data. You should see it as well. And as you know, the demo file has been deleted, but I think you can create a demo file, correct? But let me just put this demo file right here. See what this one has. Yeah, I'm going to load the demo file as well, okay?
Yes.
Okay. Like this, you have everything.
Have you loaded the demo file?
Yeah, I'm going to load the demo file as well
Okay.
right now. Okay, here's the demo file. There you go. No, guys, you have everything.
Yes.
Okay.
Thank you.
Are you welcome anytime? So please make sure if you have any questions, just send me an email, and I'll be more than happy to answer
What's
all
your
your
email?
questions.
What's your email address?
Okay, let me write it for you right here. I think some of you sent me an email. You got it, guys? prof_Kamir@yahoo.com. Yeah, just make sure to send me an email. If you have any question or anything, I'll be more than happy to assist you.
Prof_.
Prof_Kamir, my last name, K-M-I-R.
Okay.